Welcome to our YouTube channel, Equation by Pharmacist Moms, where we delve into the fascinating world of pharmacy. Today, we're embarking on a crucial journey, understanding the fundamentals of dose calculation in drug administration. Whether you're a healthcare professional, a student, or simply curious about how medications are dosed, this video is for you. Understanding the principles behind dose calculation is essential for ensuring the safe and effective use of medications in clinical practice. We have already discussed key concepts in our previous video. In this video, we'll break down the formulas and techniques used in calculating drug doses. From basic conversions to more complex dosage regimens, we'll equip you with the knowledge and skills needed to navigate the world of medication administration with confidence. Whether you're administering medications in a hospital setting, managing prescriptions in a community pharmacy, or studying for your pharmacology exams, understanding dose calculation is a fundamental skill that can't be overlooked. So, grab your pen and paper, and let's dive into the world of dose calculation. By the end of this video, you'll have the tools you need to calculate drug doses accurately and safely. Let's get started. Don't forget to hit that subscribe button and turn on notifications so you never miss out on our latest videos. Also follow the blog, equationbypharmacistmom.blogspot.com, for articles about pharmacy, health, and diverse niches. Let's learn together and make a positive impact in healthcare. Question 1. If the dose of a drug is 200 milligrams, how many doses are contained in 10 grams? To find out how many doses are contained in 10 grams of a drug, with a dose of 200 milligrams, you need to divide the total amount of the drug, that is, 10 grams, by the dose per unit, that is, 200 milligrams. First, you may need to convert the units to be the same. Since 1 gram is equals to 1000 milligrams, 10 gram will be equals to 10,000 milligrams. Now, divide the total amount, 10,000 milligrams, by the dose per unit, that is 200 milligrams. Therefore, there are 50 doses contained in 10 grams of the drug. Question 2. If 1 tablespoon is prescribed as the dose, approximately how many doses will be contained in 1 pint of the medicine? To determine how many doses are contained in 1 pint of the medicine, if 1 tablespoon is prescribed as the dose, we first need to establish the relationship between tablespoons and pints. 1 pint is equivalent to 32 tablespoons. Now, if 1 tablespoon is the prescribed dose, then there are 32 doses in 1 pint. Therefore, approximately 32 doses will be contained in 1 pint of the medicine. This question can also be solved in this way. 1 tablespoon is equal to 15 milliliters. 1 pint is equal to 473 milliliters. To find out how many doses are contained in 1 pint of medicine, you need to divide the total quantity by size of the dose. Therefore, approximately 32 doses will be contained in 1 pint of the medicine. Question 3. If the dose of a drug is 50 micrograms, how many doses are contained in 0.020 gram? To find out how many doses are contained in 0.020 gram of a drug, with a dose of 50 micrograms, you need to divide the total amount of the drug, that is, 0.020 grams, by the dose per unit, that is, 50 micrograms. First, let's convert 0.020 gram to micrograms. Since 1 gram is equal to 1 million micrograms, 0.020 gram will be equal to 20,000 micrograms. Now, divide the total amount, that is, 20,000 micrograms, by the dose per unit, that is, 50 micrograms. Therefore, there are 400 doses contained in 0.020 gram of the drug. Question 4. How many teaspoonfuls would be prescribed in each dose of an elixir if 180 milliliters contained 18 doses? To find out how many teaspoonfuls would be prescribed in each dose of an elixir if 180 milliliters contained 18 doses, we need to divide the total quantity of elixir by the number of doses. Size of dose will be 10 milliliters. Since 1 teaspoon is approximately 5 milliliters, we can determine how many teaspoons are in each dose. Therefore, each dose of the elixir would be prescribed as 2 teaspoonfuls. Question 5. How many milliliters of a liquid medicine would provide a patient with 2 tablespoonfuls twice a day for 8 days? To calculate the total volume of liquid medicine needed to provide a patient with 2 tablespoonfuls twice a day for 8 days, we first need to determine the volume of each dose and then multiply it by the total number of doses. 1 tablespoon is approximately equal to 15 milliliters. Since the patient takes 2 tablespoonfuls twice a day, the total volume per day is 30 milliliters. Patient will take 2 tablespoonfuls twice a day for 8 days, so the number of the doses will be 16. To calculate the total quantity of doses, we will multiply the size of dose with the number of doses. Therefore, the patient would need 480 milliliters of the liquid medicine for the prescribed dosage regimen over 8 days. Question 6. How many milliliters of a mixture would provide a patient with a teaspoonful dose to be taken 3 times a day for 16 days? To calculate the total volume of the mixture needed to provide a patient with a teaspoonful dose to be taken 3 times a day for 16 days, we first need to determine the volume of each dose and then multiply it by the total number of doses. 1 teaspoon is approximately equal to 5 milliliters. Patient will take 1 teaspoonful 3 times a day for 16 days, so the number of the doses will be 48. To calculate the total quantity of doses, we will multiply the size of dose with the number of doses. Therefore, the patient would need 240 milliliters of the mixture for the prescribed dosage regimen over 16 days. Question 7. How many grams of a drug will be needed to prepare 72 dosage forms if each is to contain 30 milligrams? To find out how many grams of a drug will be needed to prepare 72 dosage forms if each is to contain 30 milligrams, you can use this calculation. Total quantity is equals to size of dose multiplied by number of doses. In this case, size of dose is 30 milligrams, and number of doses is 72. Total quantity is equal to 2,160 milligrams. Then, convert the total amount from milligrams to grams. Total amount in grams is equals to total amount in milligrams divided by 1,000. Let's perform the calculation. Therefore, you would need 2.16 grams of the drug to prepare 72 dosage forms, each containing 30 milligrams. Question 8. It takes approximately 4 grams of ointment to cover an adult patient's leg. If a physician prescribes an ointment for a patient with total leg eczema to be applied twice a day for 1 week, which of these product sizes should be dispensed, 15 grams, 30 grams, or 60 grams? To determine which product size should be dispensed for a patient with total leg eczema to be applied twice a day for 1 week, we need to calculate the total amount of ointment required for the treatment. First, let's calculate the total amount of ointment needed per day. Total amount per day is equals to amount per application multiplied by number of applications per day. Since the ointment is applied twice a day, we have the total amount per day is equals to 4 grams per application multiplied by 2 applications per day. Total amount per day is equals to 8 grams per day. Next, let's calculate the total amount of ointment needed for 1 week, that is 7 days. Total amount for 1 week is equals to total amount per day multiplied by number of days in a week. Total amount for 1 week is equals to 8 grams per day multiplied by 7 days. Total amount per 1 week will be 56 grams. This question can also be solved in this way. In this case, size of dose is 4 grams and number of days is 1 week or 7 days. Number of doses is equal to applications per day multiplied by number of days. Number of doses is 14. Let's calculate the total amount of ointment needed for 1 week. Total quantity is equal to size of dose multiplied by number of doses. Total quantity is 56 grams. Now, we compare the total amount needed for 1 week, that is 56 grams, with the available product sizes. 15 grams will not be enough ointment for 1 week of treatment. 30 grams will not be enough ointment for 1 week of treatment. 60 grams will be more than enough ointment for 1 week of treatment. Therefore, the product size that should be dispensed is the 60 grams ointment. Question 9. If 0.050 gram of a substance is used in preparing 125 tablets, how many micrograms are represented in each tablet? To find out how many micrograms are represented in each tablet, you need to divide the total amount of the substance, in micrograms, by the number of tablets. Given that 0.050 gram of a substance is used in preparing 125 tablets, first, let's convert the mass from grams to micrograms. Since 1 gram is equal to 1 million micrograms, so 0.050 gram is equal to 50,000 micrograms. Now, divide the total amount, 50,000 micrograms, by the number of tablets. Therefore, each tablet contains 400 micrograms of the substance. Question 10. If a preparation contains 5 grams of a drug in 500 milliliters, how many grams are contained in each tablespoonful dose? To find out how many grams are contained in each tablespoonful dose of a preparation that contains 5 grams of a drug in 500 milliliters, we first need to determine the concentration of the drug in the solution. Given that the solution contains 5 grams of the drug in 500 milliliters, we can calculate the concentration as concentration is equal to amount of drug divided by volume of solution. Concentration is equal to 5 grams per 500 milliliters. Now, let's convert milliliters to tablespoons. Since 1 tablespoon is equal to 15 milliliters. To find out how many tablespoons are in 500 milliliters, we will divide 500 milliliters by 15 milliliters. There are 33.33 tablespoons in 15 milliliters. Now, to find out how many grams are contained in each tablespoonful dose, we divide the total amount of the drug by the number of tablespoons. Therefore, each tablespoonful dose contains approximately 0.150 grams of the drug. Question 11. A cough mixture contains 48 milligrams of hydromorphone hydrochloride in 8 fluid ounces. How many milligrams of hydromorphone hydrochloride are in each 2 teaspoonful dose? To find out how many milligrams of hydromorphone hydrochloride are in each 2 teaspoonful dose, we need to first determine the concentration of the drug in the cough mixture. Given that the cough mixture contains 48 milligrams of hydromorphone hydrochloride in 8 fluid ounces, we need to convert fluid ounces to milliliters because the concentration will be expressed in milligrams per milliliter. One fluid ounce is approximately equal to 29.5735 milliliters. So, 8 fluid ounces is equal to 236.588 milliliters. Now, we can calculate the concentration of hydromorphone hydrochloride in the cough mixture. Concentration is equal to amount of drug divided by volume of solution. Concentration is equal to 48 mg per 236.588 milliliters. Now, let's determine the volume of a 2 teaspoonful dose. 1 teaspoon is equal to 5 milliliters. So, 2 teaspoonfuls are 10 milliliters. Now, we can calculate how many milligrams of hydromorphone hydrochloride are in each 2 teaspoonful dose by multiplying concentration with the volume of dose. Amount in each 2 teaspoonful dose is equal to concentration multiplied by volume of dose. Amount in each 2 teaspoonful dose is equal to 48 milligrams divided by 236.588 milliliters multiplied by 10 milliliters. Now, let's do the math. Therefore, each 2 teaspoonful dose contains approximately 2.03 milligrams of hydromorphone hydrochloride. Question 12. How many milligrams each of hydrocodone bitartrate and guaifenesin will be contained in each dose of the following prescription? Hydrocodone bitartrate 0.12 gram. Guaifenesin 2.4 gram. Cherry syrup add 120 milliliters. Sig. Teaspoonful for cough. To find out how many milligrams each of hydrocodone bitartrate and guaifenesin will be contained in each dose, we first need to determine the volume of each teaspoonful dose. Given that the prescription specifies a teaspoonful for cough and the cherry syrup is used as the vehicle, we know that 1 teaspoon is equal to 5 milliliters. To calculate the number of doses, we will calculate the total quantity by dividing total quantity by size of dose. There are 24 doses. Let's calculate the milligrams of hydrocodone bitartrate contained in each dose by dividing amount of hydrocodone bitartrate by number of doses. Now, we need to convert grams into milligrams. Since 1 gram is equal to 1000 milligrams, 0.005 grams is equal to 5 milligrams. Let's calculate the milligrams of guaifenesin contained in each dose by dividing amount of guaifenesin by number of doses. Now, we need to convert grams into milligrams. Since 1 gram is equal to 1000 milligrams, 0.1 gram is equal to 100 milligrams. Therefore, each teaspoonful dose contains approximately 5 milligrams of hydrocodone bitartrate and 100 milligrams of guaifenesin. Question 13. How many grams of a drug substance are required to make 120 milliliters of a solution, each teaspoonful of which contains 3 milligrams of the drug substance? To find out how many grams of a drug substance are required to make 120 milliliters of a solution, each teaspoonful of which contains 3 milligrams of the drug substance, we first need to determine the total amount of the drug substance needed for the entire solution. Given that each teaspoonful contains 3 milligrams of the drug substance, and there are approximately 5 milliliters in a teaspoonful, we can calculate the amount of the drug substance required per teaspoonful. Next, we need to determine how many teaspoonfuls are in 120 milliliters. 1 teaspoon is equal to 5 milliliters. Number of teaspoons are 24. Now, we can calculate the total amount of the drug substance needed for 120 milliliters of solution. Total amount of drug substance is equal to amount per teaspoonful multiplied by teaspoonfuls in 120 milliliters. Total amount of drug substance is equal to 72 milligrams. Now, to convert milligrams to grams, since 1 gram is equal to 1000 milligrams. Total amount of drug substance is equal to 0.072 grams. Therefore, 0.072 grams of the drug substance are required to make 120 milliliters of the solution, each teaspoonful of which contains 3 milligrams of the drug substance. Question 14. A physician ordered 500 milligrams capsules of tetracycline to be taken twice a day for 10 days. How many total grams of tetracycline would be prescribed? Here, size of dose is 500 milligrams. As patient will take the capsules twice a day for 10 days, we will calculate the number of doses by multiplying 2 by 10. The number of doses will be 20. To calculate the total quantity of tetracycline, we will multiply size of dose with the number of doses. Total quantity is 10,000 milligrams. Now, to convert milligrams to grams, since 1 gram is equal to 1,000 milligrams. Total amount of drug substance is equal to 10 grams. Therefore, 10 grams of tetracycline would be prescribed. Question 15. The ORTHOTRicycline LO 28-day regimen consists of norgestimate, ethinyl estradiol and non-medicated tablets as follows. 7 white tablets containing 0.18 mg norgestimate and 0.025 mg ethinyl estradiol. 7 light blue tablets containing 0.215 mg norgestimate and 0.025 mg ethinyl estradiol. 7 dark blue tablets containing 0.25 mg norgestimate and 0.025 mg ethinyl estradiol. 7 green tablets containing 0 mg norgestimate and 0 mg ethinyl estradiol. How many milligrams each of norgestimate and ethinyl estradiol are taken during each 28-day cycle? To calculate the total amount of norgestimate and ethinyl estradiol taken during each 28-day cycle of ORTHOTRicycline LO, we need to sum up the amounts of each component in all the different colored tablets over the 28-day period. To calculate the total amount of norgestimate taken during each 28-day cycle of ORTHOTRicycline LO, we'll first multiply the number of each colored tablets with the amount of component and then sum up. To calculate the total amount of ethinyl estradiol taken during each 28-day cycle of ORTHOTRicycline LO, we'll first multiply the number of each colored tablets with the amount of component and then sum up. Therefore, during each 28-day cycle of ORTHOTRicycline LO, approximately 4.515 mg of norgestimate and 0.525 mg of ethinyl estradiol are taken. And that concludes our comprehensive guide to dose calculation in drug administration. We've covered a lot of ground today, from basic principles to practical applications. If you found this video helpful, don't forget to give it a thumbs up and share it with your friends and colleagues. And remember, practice makes perfect when it comes to dose calculation. For more in-depth articles, tips and resources on pharmacy and healthcare, be sure to check out the blog, equationbypharmacistmom.blogspot.com. You'll find a wealth of information to further enhance your understanding of pharmacy and health. Link is also mentioned in the description. Thank you for watching, and don't forget to subscribe to our channel for more informative content. Until next time, stay curious and stay safe.